Top 5 Python Libraries for Data Analysis. Welcome to Urban Flow Lab. In this video, we are counting down the 5 most essential Python libraries that every data analyst and data scientist needs to know. Whether you are just starting out or looking to level up your toolkit, these are the libraries that will transform the way you work with data. Python has thousands of libraries, thousands. But if you are doing data analysis or data science, there are 5 that you absolutely need to know. These are not niche tools. These are the libraries used every single day by data scientists, engineers, and analysts at companies like Google, NASA, and the NHS. They power everything from scientific research to financial modeling to machine learning. Let us count them down from number 5 to number 1. Number 5. Matplotlib. Matplotlib is the foundational plotting and visualization library for Python. It was created in 2003 by John Hunter, who wanted to replicate MATLAB's plotting capabilities in Python. Today, it is the base on which almost all other Python visualization libraries are built. With Matplotlib, you can create line charts, bar charts, scatter plots, histograms, pie charts, 3D plots, and much more. It gives you full control over every single element of a plot. Axes, labels, colors, fonts, tick marks, grid lines, legends, everything is customizable. Now, Matplotlib can be verbose. Creating a polished chart often takes more lines of code compared to newer libraries. But that verbosity is also its strength. You have pixel-level control over your output. It is used extensively in scientific research, engineering, finance, and academia worldwide. The code is straightforward. Import matplotlib.pyplot as plt, call plt.plot with your data, add labels, and call plt.show. That is all you need to get started. Number 4. Seaborn. Seaborn is built on top of Matplotlib and makes creating beautiful statistical visualizations incredibly easy. It was created by Michael Wascombe specifically for statistical data exploration. What makes Seaborn special is that it has built-in themes and color palettes that look professional right out of the box. No more spending 20 minutes tweaking colors and fonts. Seaborn handles that for you. It specializes in statistical plots that would be complex to create from scratch. Heat maps, violin plots, pair plots, regression plots, distribution plots, box plots, and swarm plots. All available with just 1 or 2 lines of code. One of Seaborn's biggest advantages is that it works seamlessly with Pandas data frames. You pass in your data frame, tell it which columns to plot, and Seaborn does the rest. What would take 20 lines of Matplotlib code can often be done in just 2 lines with Seaborn. Import Seaborn as SNS, call sns.heatmap or sns.pairplot, and you get a publication quality chart instantly. Number 3. NumPy. NumPy is the foundation of almost all scientific computing in Python. The name stands for Numerical Python, and it was created in 2005 by Travis Oliphant. At its core, NumPy provides the endarray, a powerful n-dimensional array object that is vastly faster than standard Python lists. Why is it faster? Because operations on NumPy arrays are written in optimized C code under the hood. When you add 2 NumPy arrays together, Python is not looping through each element one at a time. Instead, the entire operation happens in compiled C, making it hundreds of times faster for large datasets. NumPy provides a huge range of mathematical functions. Linear algebra, Fourier transforms, random number generation, statistical operations, matrix multiplication. And here is the key point. Pandas, which we will talk about next, is built directly on top of NumPy. Every Pandas data frame is backed by NumPy arrays underneath. Without NumPy, modern Python data science simply would not exist. The code is clean and intuitive. Import NumPy as MP, create arrays with mp.array, and perform operations like mp.mean and mp.sum across entire arrays instantly. Number 2. Pandas. If you watched our previous video on Pandas versus Excel, you already know why this library is so powerful. Pandas is the go-to library for data manipulation and analysis in Python. It provides two core data structures, the series for single columns of data and the data frame for full tables with rows and columns. What makes Pandas indispensable is its ability to read data from almost any format. CSV files, Excel spreadsheets, JSON, SQL databases, Parquet files, all in a single line of code. It handles missing data elegantly, performs lightning-fast Group B operations, merges and joins datasets like SQL, and provides powerful time series analysis tools. Pandas is used by data analysts and engineers worldwide as the primary tool for working with structured data. If you work with data in Python, you will use Pandas every single day. Import Pandas as PD, load your data with pd.read, _CSV, filter with bracket notation, group with df.groupb, and merge datasets with df.merge. Simple, powerful, essential. And the number one Python library for data analysis and data science is scikit-learn. Scikit-learn is the most widely used machine learning library in Python. It is built on top of NumPy, SciPy, and Matplotlib, bringing together the entire scientific Python ecosystem for machine learning. Scikit-learn provides simple, efficient, and consistent tools for the full machine learning workflow. Pre-processing your data, splitting it into training and test sets, fitting models, making predictions, evaluating performance. It includes algorithms for classification. Is this email spam or not? Regression. What will tomorrow's temperature be? Clustering. Which customers are similar to each other? Dimensionality reduction, model selection, and feature extraction. The beauty of scikit-learn is that it makes machine learning accessible to everyone. You can train a machine learning model in just 5 lines of code. Import your model class, create an instance, call model.fit with your training data, and call model.predict on new data. That consistency across all algorithms means once you learn the pattern, you can use any model in the library. Before we wrap up, let us give some honorable mentions to libraries that just missed the top 5. SciPy for advanced scientific computing, optimization, and signal processing. Plotly for creating interactive web-based charts and dashboards. TensorFlow and PyTorch for deep learning and neural networks when you need to go beyond traditional machine learning. Stats models for classical statistical analysis, hypothesis testing, and time series modeling. And Bokeh for creating interactive visualizations for the web. These are all excellent libraries, but the top 5 we covered are the best starting point for anyone new to data analysis in Python. Master those 5 first, then branch out into these specialized tools as your needs grow. Now, here is something important to understand. These 5 libraries are not competitors. They are an ecosystem. They are designed to work together. NumPy sits at the foundation, providing fast numerical arrays. Pandas builds on top of NumPy, giving you data frames for structured data manipulation. Matplotlib provides the base plotting engine. Seaborn builds on top of Matplotlib, adding beautiful statistical visualizations. And scikit-learn uses NumPy arrays and Pandas data frames as inputs for machine learning. Data flows between these libraries seamlessly. You load data with Pandas, process it with NumPy operations, visualize it with Matplotlib or Seaborn, and then feed it into scikit-learn for modeling. This interconnected ecosystem is one of the biggest reasons Python dominates data science today. Getting started with all 5 libraries is incredibly simple. Open your terminal and run one command. Pip install pandas numpy matplotlib seaborn scikit-learn. That is it, all 5 libraries installed and ready to go. Here is a typical workflow. First, load your data using pandas. Then, clean and process it, handle missing values, filter rows, create new columns. Next, explore your data visually using Matplotlib or Seaborn. Create histograms, scatter plots, and heat maps to understand patterns. Finally, build a predictive model using scikit-learn. The best way to learn is not to read documentation. It is to pick a real dataset that interests you and start exploring. Download a CSV from Kaggle, load it with pandas, and start asking questions. The libraries will teach you as you go. Let us recap our top 5 countdown. Number 5, Matplotlib, the foundational plotting library, full control over every visual element. Number 4, Seaborn, beautiful statistical charts with minimal code, built on Matplotlib. Number 3, NumPy, the engine of scientific Python, fast numerical arrays that power everything else. Number 2, Pandas, the essential data manipulation library, data frames, file reading, GroupB, merging. And number 1, scikit-learn, machine learning made accessible, classification, regression, clustering, all in a consistent, simple API. Together, these 5 libraries give you everything you need to go from raw data to insights to predictions. Thanks for watching this Urbanflow Lab video. If you found this helpful, please subscribe to the channel, hit the like button, and leave a comment telling us which Python library is your favorite. In our upcoming videos, we will be diving deeper into each of these libraries with practical examples using real engineering and data science datasets. See you in the next one.